Hi, Joe Cerrone,
And Al Rosen.
and we're going to look at Module 2. This is our weekly Zoom meeting, and so Module 2 covers multi-view drawing. If we go to the Content tab and we look at Module 2, we have a PowerPoint lecture, and then we have a video on how to do the exercise. There's a drawing sheet that students will use to complete that exercise. And then there's a lecture on how to do that. So if we start by looking at the multi-view, let's look at the lecture, and we've embedded it in the main splash page. And so here it is. Multi-view drawing, our objectives are basically to be able to explain how multi-view drawings are used. And you have to remember that CAD has not been around forever. We used to draw on paper, and it's not possible to do these three-dimensional drawings except for maybe like an isometric drawing technique versus the modeling. So the way that drawings were represented on paper was with orthographic projection, or front, top, right side views, and even auxiliary views. And so this was multi-view drawing. There's standards. We use this ASME, American Standards of Mechanical Engineers, Y14.2. Talk a little bit about line standards. Line standards would be object lines, hidden lines, dimension lines. We'll look at the difference between first angle and third angle projection. And then basically we'll go through and look at how you create these multi-view sketches. And we'll make them with CAD. So here's the big yellow school bus, Al, takes, right?
Yep. And in the front with two headlights, it's a front view.
Yeah, no doors.
No doors.
Just windows.
Yep.
And as we look at how we describe different views on paper, we line them up. And so you have a front view, and then the edge of this back of the bus is lined up with the edge in the top view and in the bottom view. And then as we project over to the side view, the right side and left side view, everything kind of lines up. And so the way that engineers and technical people would be able to see what was where was to project over the different elements from one view to the other. So we
go ahead. You have to use T-squares, triangles,
pencils.
Yep.
And so, you know, here's 6 of the regular views of the drawings. And again, you know, they're all lined up 90 degrees to each other. Same thing for an architectural drawing. And so as we look at it, you know, we have a front view, a side view, and a top view. And this box, or this cube, kind of represents the viewer's line of sight. Front view, right side view, top view, and then the things within the views line up. So the roof line should line up exactly with the views. The chimney should line up exactly. When we get into projecting three-dimensional objects onto two-dimensional paper, there's a technique for that. And so as we look at this part, it depends on which viewer line of sight we're going to project off of. And so from a front view, you can see how this object would look. These triangular shaped oblique surfaces, and they're called oblique because they're not perpendicular to the line of sight. They're not flat, they're at an angle. And so the circle is perpendicular, so it appears round. If it was at an oblique angle, it would appear like an ellipse. And so these are not true size as we get into creating these shapes in two-dimensional paper. And again, here's another line of sight from the top view. Essentially what we do is we take and project off of each of the corners. And we would use T-squares, triangles to project these type of views one side to the other. Normal surfaces, flat, perpendicular or parallel to the frontal projection plane. So when they say parallel, they mean they're parallel. When I say perpendicular, that would be this line here is perpendicular to that line. And so we pick up on some new definitions like a normal surface. A normal surface is something that would be parallel to the plane of projection or flat. Inclined surfaces are not flat or are not parallel. And so they tend to be what they would say foreshortened, or they look narrower than they really are. And that's an example of an inclined surface. And so when we do these orthographic projections, we often have to project off a true size view, or we used to back when we had to work with pencil. Nowadays with CAD, we can model the part and project all of these views automatically. So the use of the CAD system is a real benefit to this type of work, because it was really pretty tough to be able to represent three-dimensional drawings on two-dimensional paper. And so here's these oblique surfaces, and oblique surfaces, again, are not flat. They're inclined. And so here's some more terminology. The oblique would be inclined in more than one view. And then the old school way to do this was you would go through and you would number each of the corners, 1, 2, 3, 4, 5, 6, 7. I would have gone up instead of around. And then if you look in the top view shows that 16 is at this point, and then 17 is actually down here underneath it, because this is flat, it's directly below it. And so you'd go through and you would number all of the different points, and then you would work on how to project those from one view to the other. And so you have this glass blocks technique. And then if you unfold that glass box, you can kind of see how everything looks in a two-dimensional view. Hidden lines in multi-views represent features that are not visible in the view. And so when you look at the side view, this little cutout here would not be visible, and so there's a dashed line. When you look at it from the side view, you would not see the hole, and so the hole is represented with dashed lines. And then the center lines are representing the center of the arcs, and so the middle where that's at. And so proper terminology would be to put a center mark at the center of a circular or round feature, and then to project off the proper views and put the dimensions on it. And so visible lines, okay, object lines, typically represented with a little bit darker or a little bit heavier line weight. And when we start setting up our CAD standards, we'll set those up at 0.6 millimeters. And then center lines are a little lighter, they're thinner. And so you would set up a line weight of 0.3 millimeters. Same with hidden lines. And so here's our standards for line thicknesses. Back in the day, we would buy a different pencil. So you'd have a pocket full of pencils with a pocket protector, and you draw the visible lines with one pencil, the hidden lines with another pencil, and they would have different leads as well. So the softer leads were darker and the harder leads were lighter. And so you would use like an HB lead for a visible line. And then for a hidden line, you might use something like a 2H or a harder lead. Here's a representation of pictorial. Pictorials are always easier to understand. You can see what a three-dimensional object is, and we're kind of used to that nowadays. And then just some things as far as the process of how you would orientate the part in the view. You really want to keep it so that the flat edges are normal to the views, or flat, perpendicular or parallel to the reference planes like this. And then they show what the outline of the objects would look like. This would be the object lines, the visible lines, which you would draw with a 0.6 millimeter line weight. And then we would go through and add the hidden lines and the center lines, which would be with a 0.3 millimeter. And you can see, you can start to understand what the interior features of the part is. And it allows us to manufacture that. So once we have all the lines drawn in, then we go through and dimension it. Dimensions give all the values or all the sizes necessary to manufacture that part. So we need to know the location of this hole, and this hole is located 2 inches from the bottom edge, and it's located right down the middle or on center of this 3-inch part. So that would be 1.5 inches over, or directly at the center of this other arc. The key to being able to dimension objects is not to put the same dimension on twice, just one time, so that you have one reference, because you can get tolerance errors if you have more than one dimension on it. So here's some basic shapes, and this is kind of what we're going to be doing. Here's a rectangular shape. Here's what it would look like from the front, top, right side view. Front, top, right side. Another one, front view, right side view, top view. Cylinders would look like rectangles in the right side view and the top view. Geometry with holes in it will have hidden lines and center lines representing where that hole goes through. And the same for our pipe drawings. You know, you can tell by looking at this 2-dimensional drawing that it's hollow because it has a hidden line. And once you understand how to read these drawings, you can see that that would make it a tube. And so we'll be going through and creating shapes like this and doing the front, top, and right side view in our exercise. Here's an example of a cone, how that would look in 2D, and a sphere, how that would look in 2D, top, front, and right side view. And this is the technique of orthographic projection, where you'll draw the front view of the object, and then you'll project over the height dimensions to the side view and the depth dimensions over to the top view. This is called a miter line. So what you can do is you can actually bounce the dimensions off of the miter line into the top view. So if you bounce this view, this line from here to here, and this one from here to here to here, you'll have the Z depth, and the Z depth is the same in the top view. So again, how to do some basic orthographic construction. Draw the front view and then project over the side view and the top view. We always try to draw our objects to scale. Our work in AutoCAD will be full scale. We don't necessarily need to scale them like we would on paper with a pencil. We'll use viewports to do that. And the same thing for our architectural drawings. Drawing paper sizes. A regular standard size piece of paper is 8.5 by 11. That would be an A size. B size paper would be twice that size, or 11 by 17. And then C, 17 by 22. So the paper size is double in one axis for each increase in letter size. Third angle projection is what we use in the United States. Third angle projection would mean that here's our front of our bus, and then the side view would be located here, and the top view over here. Whereas first angle would put the front of the bus at the back of the bus. I believe they use some of those standards in Europe. There's a symbol that's put onto the blueprint that tells them which angle of projection they would use. And in summary, what we're looking at is how to be able to visualize top, front, right side drawings, the 2-dimensional aspect of it, because it's not unusual to go into the blueprint room, pull up an old print. And I used to do this when I worked for Komatsu Dresser Industries. We had prints from the 40s of these machines, and they were drawn with pencil, and we would take them and we'd have to know how to read those drawings. And so it's very common to be able to use multi-view drawings, and we're going to show you how to do that with CAD. So the way this assignment works is that we're going to do these multi-view sketching exercises, and we'll begin with these different drawings right here. We have already given you the template for that, and so we're going to draw these different objects right here, and I'll get started with that. So I'm going to leave this on the page. I think I'll move this over. Actually, I'll have to leave it here because I'll lose my screen. We go here.
So you want to explain to them each one of those squares is a certain size, and that's how they get their exact size and proportion to draw.
Right, and so as we open it, you'll see that all of these squares are set. They didn't dimension them because they put a standard grid size on it. So you're going to download the multi-view grid sheet, DWT, which is a template file, and then we're going to open that. And this is what you'll have. And I'm going to switch this layer over. I'm surprised it didn't come up as layer 0. So we have our object line. And then I'm just going to zoom in on that area there. We're going to take a look at our drawing. And you just basically count squares. And so if we come over here, we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares down. So we'll start our front view by going to the line command. We'll bring our cursor right there, and then we'll go over 10 squares. Each square is 1 unit, so we'll go 10 units over, click, and then we'll drive that up 3 units, and then we'll drive that over 3 units. We'll drive that up 3 units. We'll drive that over 4 units, drive it down 2, and then over, and then back down. Hit escape. Usually there's a line weight on this, and layer 0 is locked, and so it may be better to use a different layer or to unlock this. And so I'm going to unlock this layer 0. I probably could have done this I should have done it on the visible line layer. So what I'll do is I'll just transfer it to that layer. Here's how I would do that. To transfer it to another layer, you just select it and then select the layer visible. And since it's locked, it won't let me do it, so I have to unlock it. And then we'll do it again. There we go. And then I'm going to use the visible layer for the rest of it. So that's our front view. And then the right side view of this object, if we look at how that's going to lay out, it's basically going to be a square or a rectangle and another rectangle above it. And so as we look at it, we'll have a rectangle that's going to go 3 units up and 4 units over. So we'll start with a line. From this point, we'll go over 4, we'll go up 3, and it's going to go all the way to the top. So I'm just going to draw this shape like this, hit escape, and then this edge here is visible. So we'll project that over, and then we'll switch over to a hidden line layer, and we'll draw the hidden line, which would be right here. Like that. And then we'll draw the top view. You can use the miter line if you want to project it. And so if you want to project, you can go from here to here to here. And it basically just winds up in the back to here. And that'll be 4 units up. And I've drawn it on the wrong layer. So again, I'll have to fix it, select it, and then go to the visible line layer.
Joe, you want to explain to them that as you select on a line, you don't go all the way across. You can pick up, if you have the front view, you can hover over one ends, corners, and move the mouse over.
So that's what the first object will look like. front view, top view, right side view. The top view doesn't have any hidden lines because there's no hidden features, and neither does the front view. And so when we look at the next one, we'll do this circular tube shape, and this would be set up with 1, 2 unit radius. And so we'd start with a circle, and I would count basically 2 units over and then 2 units up. Somehow one of the lines got deleted from this, so I'm going to have to put that back by copying it. There we go. And then we'll start again with a circle. We'll go count over 2 units, we'll go up. It'll be like that. Have another one like that. And then if we look at the view of the object from the side, 1, 2, 3, 4, 5, 6 units. And so we can start with a line here, bring that over 6 units. It's going to line up right like that. And then we'll change over to the hidden line layer, and we'll project over these lines. Switch over to a center line. I'm going to change the color of the center line by clicking that square there. I'll make it red. And as long as we're changing colors, let's do the same for the hidden line. Let's change that to green. And you can see that it updates. And so when we do the center lines protrude from the object like that. And then when we do the top view is going to look exactly the same as the side view. It's not really necessary, but for this exercise, we're going to draw it. And so we'll come over 6 units, I believe that was. So we'll come down 6 units, over, up, and back. Switch over to the hidden line layer. Right mouse click, saves you a step. Change to the center line. Center lines protrude from the object. And we can also, because I'm so picky, there we go, put a center mark on the center of the circle by going to the Annotate tab and using a center mark creator by clicking on this outside radius. It'll go through and add that. And then our plan is to draw each of these objects and then to be able to model them. And so when we start going into the advanced applications in the AutoCAD comprehensive textbook, what we would do is we would be able to take this object and we'll say copy with base point. Not exactly what I wanted, but it'll work. So we copy that object over, and then what we'll do is we'll take a isometric view. And this is not required for this exercise. I'm just going into what we're going to be able to do with it. And so we can model this by using press pull command. Yeah. And so let's go to our layer 0. We'll say press pull. We'll hover, click, bring that up. If we use a visual style like conceptual and then press pull it, we can then bring that up 6 units. And that's kind of where we're going with it. And so we'll start off just by creating these simple shapes, front, top, and right side view. and then we'll model them. And the reason that we model them is because once you learn how to model, you can automatically generate these with what's called a flat shot. And so there's a method to our
Madness.
technique. Yes. So the assignment then is to do these 9 parts, front, top, and right side view on our grid. And then to save that, so we'll go File, Save As. And then we'll save that with your initials, dash lab 2. Save. And let's put it in the right directory. All right. So that's the basic lab number 2 exercise. You will take that once you have completed it, and you will put that into D2L. And so under the assignments area, module 2 is where you'll submit that, and then Al will go through and grade that. If we look at module 2, it will be graded on completeness, graphical accuracy, using the proper design rules, proper dimensioning. There's no dimensioning on this, but as long as it's accurately created. And then construction manufacturability. Is it at the correct scale? Is the material properly noted? Some of these aren't necessarily going to play into a factor. It's mostly going to be completeness, graphical accuracy, and these rubrics then will carry over into some of our other part designs. All right, so with that, I'm going to bring you back to the home page. And then Al, is there anything I need to add before I stop this video?
Yes, if you were going to send us an email or whatever to Joel, myself, or both of us, hopefully, someplace in there, making sure you put down your class. Is it CAD-116, 050, or 117, 050, whatever the case be, please. They'll be making our lives a little easier for us.
That's right. We're getting some emails from students, and they're saying, I'm having a problem with, lab 2 or module 2. And it's like, well, which class are you in? So we have to go through all the classes and find that student. We've got about 5 or 6 classes running this semester. All right. Anything else, Al?
Yeah, just make sure when you're doing your drawings, you make sure you have your snap and grid on. That'll make your life a lot easier for this portion of it. Or if you want to put your orthographic on it, graphic projection onto it, that might help you increase your line, making sure it's straight and correct.
Yeah, definitely. And since this is our intermediate course, we kind of figure most of you guys will have those skills. If you do have, like, if you do need some review, it's been a while, just send us an email and we can create a meeting for you. All right, with that, I'm going to stop this video and we'll post it.